It is time to conclude this chapter. We have mentioned series of denoising algorithms, all starting from this noisy image and aiming to get to the ideal one shown on the right top side. Let's rank these methods. The global thresholding is the weakest of all. Non-local means, which will be presented later, is somewhat better. Patch-based filtering with learned shrinkage got quite close to 30 dB from below, while the simpler patch averaging did slightly better. Perhaps this could be explained by the ineffective training of the curves on images of different nature. KSVD denoising performed quite well, and we have seen several methods that improve over it. BM3D gave the best results we have seen on the Barbara experiment. So who is the best performing denoising algorithm? For a while, this was the drive in developing new methods. And indeed, over the past 15 years, we have seen an evolution of methods showing a consistent improvement in the denoising quality. When we compare performance of denoising, the common approach is to use a fixed and known set of test images and series of noise levels to experiment on. The output quality is measured in PKSNR, as we did throughout this chapter, or using more sophisticated measures such as the structural similarity between images. The lead today is held by an algorithm called TNRD. Is it related to SparseLand? The answer is partially positive. Leading methods today are all learnable and has some connections to neural networks. TNRD proposes a specific architecture that is closely related to the field of experts, which in turn is related to the Course2 analysis model, a variant of SparseLand that we chose not to cover in this course. An interesting observation in recent years is that the better performing methods, while quite different from each other, lead to nearly the same output quality. This may suggest that we are getting close to the ceiling in denoising performance. Well, are we touching the ceiling? Two amazing papers ask exactly this question. This one by Milanfar and his student from 2010 suggested an intricate analysis that led them to the conclusion that there is still room for improvement. The other paper by Levin and Nadler, published a year later, got to the opposite conclusion using a completely different methodology. We should say that their pessimistic conclusion referred to algorithms that operate only on small patches, so perhaps this explains the gap between the two works. The bottom line to all this story is this. Image denoising was, and still is, a central problem in image processing. Thousands of algorithms were proposed over the years to handle it. The emergence of sparsity into our lives led to a boost in denoising performance. The more recent comers to this game are based on deep learning. Amazingly, recent work by Papian and others shows that these schemes are also connected to sparse modeling. So my conclusion here is that sparsity methods still leads the denoising arena, and maybe this is true more broadly to all image processing.